Very good evening. I welcome you all on behalf of IIPE for this evening technical session on the topic generator and protections with digital solutions. I would like to introduce our speaker of this evening, Mr.R Srinivasan. He is currently Director, NIDAC Industrial Automation India Private Limited, Bengaluru. And he looks after sales, service and application engineering. He's having close to 30 years of experience in electrical industries, in handling rotating machines and electrical equipments, power station, AC generators, HV and LV, AC DC motors, wind generators, switch gears, drives and UPS with latest technology, excitation system and digital solutions. Mr. Srinivasan also served in leading engineering and manufacturing industry earlier. He was with Mrs. LG Electric Industries Coimbatore, Mrs. Larsen Tubro Limited Mysuru and Bangalore and Coimbatore. He also worked in Immersion Industrial Automation Bangalore. Currently, he is with NIDAC Industrial Automation. He is also Joint Secretary of IIP Karnataka chapter. A warm welcome to Srinivasan. Mr. Srinivasan, thank you for joining us. Over to Mr. Srinivasan. We are eager to have your technical session. Over to Mr. Srinivasan. Thank you.
So, first of all, thank you, Mr. Prakash ji, for a small introduction on that, and thanks a lot for that. And thanks IIP for giving this platform to share the technical knowledge sharing. In coming to the overall situation on the system, I would like to first of all thanks for the people joining this particular webinar, and the Dasara wishes to all the members to in and around. So to start with our presentation today, the technical topic, what we are going to discuss on the one. So it is more on the, yeah, I'm sharing my screen. Is my screen visible?
Not visible, sir. You have to share your screen.
One minute, I'm just trying. Okay, to the participant, you can able to see the screen now?
Yes, please.
Okay, thank you. So today's topic, what is going to be discussed is a generator and its protection with the digital solutions. Myself, Srinivasan, I'm working for a company, as Mr. Prakash was briefing, a company called NIDAC Leroy Somer. So I'm representing India after sales service and applications. A small brief about Leroy Somer. It is a 100 years old company. In 1919, it started its manufacturing of alternator globally. You can see the slide. What the presently it is on the global map where we are on the system. Right from India, we have a factory in Bangalore and Hubli, and we have factories in Europe and of course in America. So technically, this is a design of a French design, European design, we would say, about 100 years old design. So we are also having the same design in a global market. So I'm representing the company Leroy Somer India. So going into the our discussion on today's topic, we'll be talking on generator on low voltage and high voltage, how the generator is constructed, winding, how the winding is being done, and it's on LV or HV, and generator insulation and temperature rise, which is very important on the system. Generator bearing, whether it is a single bearing generator or double bearing generator, and generator insulation, LV, HV generator. So we'll be specific touching on the HV generator insulation also. So, and comes the second topic, a generator excitation system, which is also a hot of the for the generator. it to give the voltage regulation. So we'll be touching on that types of excitation system in the synchronous generator. And we are more important how this generator protections are controlled by digital areas and also from the control system. So this is the three topic we'll be covering out, across on the system. So this will be added one in that. So before going into the topic on any of the questions and answers will be answered on the final one, and we will take it, or you can text it as Mr. Prakash was mentioning. So coming to the generator, to have a platform where all this generators is working. You can see the platform like the commercial and industrial building on the left hand side of that, building and construction, telecom, aviation, wind, data center, marine, defense, railways, prime, power plant generation. The generator is very much required. This is a critical equipment, we can say, or a plant and machinery. It becomes a prime one first to be required for any of the projects, apart from the HD substation or the LV substation, what is going to happen. And recently you can see a prime movement what India has been done with Vibrant about the Vikrant ship. India made one that is also powered by 24 gigawatt 24 megawatt power on the generator. So it is also giving a for the defense application. Our Vikrant which has been done for it is being powered by generator. So going into that, generator types, how it's been manufactured or systems. So generator, you normally in India they call it as an alternator, but AC generator has got AC generator and DC generator. In AC generator, there are two variants. It is a brush type and brushless. Fundamentally, during 80s we had brush type alternator. Presently, it is moving on with brushless. Brush type alternators are very rare, and conventionally on the maintenance front, it's been absolute now, I can say. Coming to the asynchronous generators like induction generators, we also have a talk on that, small on that. This is more of a wind generators, we have it. But induction generators have been given with some motor applications and other this thing also where it can be dually operated. So that is also been given in the system. So coming to the our India, I'm just covering as a India. In India, the low voltage machines have been converted 250 to 650. That is a medium voltage, low voltage, and low voltage will be up to 250 volts. Medium voltage will be 250 to 650. High voltage will be 650 to 33 kV. Extra high voltage is above 33 kV. So this is the fundamentals of our voltage requirement, where our grid supply, where the electricity board of India is supplying that. So we as a generator manufacturer has to give a supply which is in line to the system requirement, whether it is domestic, commercial, or industrial. So that is where we are on that. And there are a lot of preference voltage in India, like you can see in a single phase, more of the domestic household items are 230 volts. Of course, in the commercial buildings and apartment, there are people are preferring for three phase, 415 volts, three phase, 3.3 kV, whereas the input supply, where if it goes more than 1 megawatt, people go for 3.3 kV and 6.6 kV. In case of any long distance travel, the more the voltage, the low voltage drop will be less, so higher voltage it's on. So on, it goes up to 400 kVA, but in generator, we limit up to 11 kV. There is a reason for that. When we talk on the insulation, we can able to bring it across. Of course, we were discussing on the DC voltage generator. Predominantly, it comes in 220 volts and 440. But generally, DC voltage generators are very, very less in the operations, where there is a conversion of AC to DC, DC to AC, and convert to for that. So there is a good amount of brushless generators, which is with AC voltage is very evident and proven design in global market. Coming to the generator, single bearing and double bearing. The left hand side of the generator, you can see the single bearing. What do you mean by single bearing is the disc is directly coupled to the engine flywheel. So that means it becomes a prime mover. It is coupled to the prime mover. In case of a double bearing, there is a two bearings on that. One is on the DE side and the NDE side. So conventionally for the turbine and other applications for the shaft generator, marine, they go for a double bearing, where the torsional load sharing will be better. But conventionally, this is also for single bearing presently up to 2.5 megawatt. It has been proven design in single bearing, and it is more of a cost effective one where you are eliminating one bearing and also one bearing in the engine side. So it's directly coupled to the flywheel, become a single axis. So there are some SAE standards on that. If any requirement on that, I can able to share that about the SAE standard. It is about matching from SA1, SA2, SA3, SA0 and 00. So there are standards on that SAE, which has been generally used. Presently, with all the engine manufacturer you name, from Caterpillar or Close-Coil engine, Mahindra or Ashok Leyland, everybody goes with the standards of this SAE, wherein the coupling is mating point is well matched. Marriage happens in a better way. Coming to the turbine segment, of course, when there is a steam turbine or hydel or for the marine application or shaft generators, so the double bearing is preferably preferred for the torsional value and the torque sharing. So this is where I am just talking about. You can see that the alternator is coupled to the engine prime mover, and it can able to see the rotation prime mover and the alternator. So this is our generator, which we are going to move on. So generator construction is something like exploded view. You can see that the parts which is being scattered, you can see what are the parts are there. Maybe by identifying it, maybe I can able to share you some more information. This is what I'm just showing an exploded view of a single bearing alternator, wherein there is no DE bearing, only a ND bearing you can see, and there is a D adapter followed by fan. There is a main rotor and main stator winding. This is a terminal box where the output lead can be connected to the terminal bars. And of course, there is an exciter, which we will discuss on the excitation system. And there is a RRA rotating rectifier assembly in the small parts, and the ND shield, which is holding the bearing of this. So this is the exciter stator, which will be a two-mission system, which we will discuss during this part. So this is where the generator construction starts, like what you have seen. From the left-hand side, this is again a flexible disc, and there is a flange, there is a shaft, again fan, rotating, that is a rotor winding, stator winding, stator frame, bus bars for the bus bar, or you can make it as a lead wire connection for the output cables. Then a terminal box, which is very, very important as a protection part, where will be a IP23, IP55 enclosures have been given based on the customer demand, and the leads are being connected, and outgoing power has been removed, taken from this point of area. And we will be talking about the rotor assembly, where there is a diode, a rotating rectifier assembly, and the ND bearing, and the exciter rotor winding, and the exciter stator. So which we'll talk on the further in our slides. Mr. Prakash, is my audio is okay?
Yeah, okay, sir. Fine, fantastic.
Okay, fine, thank you. So coming to the how the manufacturing process happens in the alternator, these are the stampings which will be used, and the stamping has been made as a profile to the slot. Maybe it is required 48 slots or 60 slots or 70, 82 based on the design. So this core stacking has been done, and further to that, stator assembly, welding done, winding done, after that impregnation. So this is something like a machine has to be prepared in a system where you can able to see a stator assembly comes on one area, and rotor assembly, the same process. You can see a stamping and built into the core, and after that the wound copper has been done on the each pole. This you are seeing as a 4-pole, where you can see the 4 windings, and again it is going to be a VPA process. And one that is being completed, you can see the rotor assembly has been built like that. So where the disc will be fitted over here, this is a fan, and the winding over there, and exciter, rotor, and RRA, and the bearing comes into that. So in the whole scenario, it's a 2-line system. It comes our ND shield and DE shield. So this becomes a double bearing alternator with a platform for AVR and control parts like differential CT or metering CT will be fitted, which will be coming in our further. So once this generator is built, it goes for a testing. So this is a integrated manufacturing process of a generator, right from stator to the rotor and complete machine, what you get in the market. So I just want to give a small touch on that, what we have seen in previous one. And this is a cut section of our generator. You can see a rotor winding and the stator winding, you can see here. This is a terminal box. From that, lead wire has been taken to the termination. And this is our exciter stator and exciter rotor. And of course, very, very important, looks very small. It's a QDC, quadrature troop CT, which is used for parallel operation. So this is a cut section of the generator, what we are seeing it across on the system. Coming to our generator winding, of course, there are in a generator, it is a 3-phase 3-wire system. Normally, we know generators which has been on a star connected one, where it's a 6-lead connection and a 12-lead connection. There are delta connected generators also, where the voltage will be different based on the requirement. For the voltage, what we have discussed previously, it is a 230 volts or a 3-phase 3-wire system, or a 3-phase and 4-wire system. Generally, this is a 6-lead connection and 12-lead connection which has been taken, where the neutral will be taken the star point of that. So this is how it goes. And there are 3-phase 6-lead connection, 3-phase 12-lead connection, where you can do a multi-voltage connection, and single-phase dedicated winding for the telecom application and the commercial household requirements. We have a dedicated single-phase winding. Coming to the insulation system, the insulation for copper, which is very important, there is a dual coated insulation on the bare conductor of the copper, which is an electrical grade, and insulation for the coils, mica for the high voltage for the machines, slot insulation, which we'll discuss when the core has been built. There is a slot on the stamping, so there is a slot insulation has been given so that there is no short circuit happens to the body. And slot closer insulation, again, after the winding, we prepare one more insulation over the winding. And face-to-face insulation. This is going to be an insulation which will be given between the face-to-face, that means R phase and Y phase or B phase, which you will be seeing in the next slide. Face-to-face insulation, the coil in the overhang. That means when the winding has been formed over, there is also one more insulation comes on the overhang. And pole winding insulation, this is a main rotor where you will have each pole, there will be an insulation to be provided, which is very, very important. Like it is more of our skin, which is not allowing the other things to safeguard our inner skin. How is our layer of skin is created, insulated, like that the insulation is very important for the generator. So insulation of the connection leads on termination, where after the complete winding, it goes for the vacuum impregnation process, which is a VPI, very, very critical process in the generator manufacturing. And winding overhang, which we have for the coastal application or a moisture environmental reason, there is one more coating varnish will be done for the winding to prevent from that environmental condition. So coming to the generator insulation on the mica tape, where the class of insulation is there, class H insulation. There are insulation with the temperature rise, where the ambient temperature has been considered as a 40° in India, pan around. Of course, it is very unique. Rajasthan has got more than 48, or Delhi, we have invariable different. So considering ambient temperature as a standard, there are class F and classes insulation, but predominantly the temperature rise, which has been considered to the customer demand or requirement, the present generators are manufactured with class H insulation, which has been one of the predominant for the high voltage machines, where the epoxy also plays an important role, which we use it in that. So for example, when we do a high voltage test or a surge test, such things requires insulation is very important. And one moreover, the generator is going to develop a low voltage up to 415 or a high voltage up to 11 kV. The insulation scheme is very, very important. That's what we have been giving to the market on that. So to have a common understanding, to put it in a perspective, one is thermal class, it is a class B, and it is a maximum temperature rise can go allowed is 130°, and allowable temperature rise from ambient you are allowing up to 80°. This is why we are talking on that. If you are going to set any temperature sensors, that means for a winding temperature, you keep monitoring it. So there should be a tripping circuit where the temperature can be set across, so that the winding or the any of the temperature rise can be determined. Like F class, again, the maximum allowed temperature is 155°, and maximum allowed temperature rise is 105°. So here we have to consider that ambient, where you can set it across, so that ambient 40 plus 105, which is 145 is your temperature set, you can give it for a trip. This would say in case of any of the temperature rise of the winding goes beyond 145, the controller has to trip. So this is fundamentally a information to the customer and the commissioning engineer, as well as the operation maintenance engineer, follow this setting on the parameters. So why I said class H insulation, you can see the temperature, which is 180 degree, because today everywhere the temperature variants are there. Of course, in India, as I said, there is a 48 degree in Rajasthan, and some point of where you can in Andhra, Vijayawada, as well as you can say in Nagpur, where the temperature can even go up, touch about 50 or 49. So in those area where the summers, the class H insulation, so this becomes a predominant where the generator canopy and other things where the temperature can go up to even 50 degree or 45 degree. So generally the customer requirement has moved across from very late 80s. We had about class B. Now currently it is a class H insulation is a present demand from the customer or from the electrical inspectorate also. So this is the HT coils. You can see the HT coils of that. Earlier I was just talking about the insulation, the wedge, the phase separator and this is one, the HT coil which we are talking about. So this is a slot edge after the winding. We put the wedge over here, you can see this. And there is a carbon tape which is put across for the to discharge the flow of charges on the slot mouth. And a separate semiconductor tape is stretched over that. In case of any high voltage, there is a movement of coil due to the electromagnetic force. So this is being put across as a part of extra insulation on the HT coils. And of course, the carbon tapes have been given, and this after this goes for the VPI process for the HV generator insulation. So HV generator insulation scheme is altogether different from a LV generator. So that's the reason I thought of sharing this information. So you can see to the team, maybe you can have a guess which is LV and HV. I think I have a 2 to 3 seconds. So this is a HV generator coils. This is how the insulation of the winding formed coil looks like. On the right hand side, you can see this is how the HV coil of the generator looks like. So predominantly, which is what discussed, there is a carbon tape, and over that there is a different one. This is fitted into the winding. This is how it looks. This is again a LV winding, and this is a HT stator winding. You can see the phase separator, slot mouth. We were talking on this. This is a slot mouth insulation. This is a phase separator insulation. Overall, it is binded with the insulation tape. So this is the DE side of the winding, and the other side of the ND side of the winding. And here you can see the HT side, DE side of the winding, where you can see the lead wires have been brought and the insulation has been done, and this has been brought to the terminal box for control wiring or putting your CT. So this is the LV generator terminal box, and this is the HT generator. Again, in LV generator, as we were discussing, there are some protection required on the current and QDC, which has been inbuilt, where the customer can connect the outgoing cables. This is the neutral RYB, and this is the neutral one where the customer can connect. If it is a vertical one, even the customer can go for a sandwiched bus bar connections where the terminal can be connected. So this can be LHS and RHS can be done on the way, whatever the customer. This can be one before requirement. We have to inform the manufacturer who is going to select on the generator. The same like the HV generator, where you have the PTs and CTs being fit across, and the output cables has been taken. So this is a three-phase star connected, and the neutral takes from here, and the phase RYB for the 11 kV output is taken from this. So coming to the protection part of which I was mentioning on the generator, where the CT is very important, current transformer. CT means current transformer, where the capacity of the CT is very, very judiciously required. Most of the time, the people who buy the generator, they miss the protection part, which is very, very predominantly, we buy a generator for a lakhs together investment, but protection is compromised. In that case of that, presently there is a requirement from electrical inspectorate. This is supposed to be calibrated. The CT is must, and it should be calibrated every 2 years, and the certificate has to be submitted to the electrical inspectorate. And the norms are also going to be very stringent, very back. Maybe we can discuss on in later stage on that particular forms of the electrical inspectorate and the pollution control board during next meeting. This is the differential CT, which is very important. There are two ways to look at the system. One is for the generator safety, another for the human safety. For the generator safety, we do body earthing, and more of the winding. If you want to have a generator to have a damage to any of the surge voltage, surge current, this differential CT is very, very important, which can be that. Thanks to our latest technology of the designers, they give the differential CT inbuilt in the generator terminal box. Historically, this was not there in 90s. It was being put in the panels. Today, everybody talks about the compact design and other things. So our engineering, re-engineering happened, or value engineering happened to put everything accommodated in the generator. So this is one of the innovative ideas where the customer demand has been made to put this protections and CTs as well as the metering CTs and the differential CTs in that. So very, very important to the system requirement. Coming to the excitation system, I'm okay. My speed is okay, or you want to slow down, Prakash?
It's okay, sir. Please go ahead.
Thank you. So coming to our excitation system, this is a hot-off system. As you all know, our entire things works with two. One is brain, another one is heart. If two of things are down, things are different. For generator, the excitation system and the AVR are the two working on equal. I will put it as an excitation system as your heart, and AVR as your brain. This is how I can put it to have a comparison. So in the excitation system, there is a shunt excitation, there is a separate excitation, and RF excitation. So three variant of excitation can be done in a generator. How it can be done? So this is a shunt generator. If you can see this, this is a shunt generator. This is the outgoing leads U, V, W, N, and this is a rotor winding, and this is a stator, and this is a rotating rectifier assembly where the exciter stator and exciter rotor. And this is the part where it is going to couple with a prime mover, engine, or a steam turbine, whichever it is. So in the case of this exciter plays an important role to feed the voltage to the main rotor. So this is a winding we have seen in the main rotor. So it feeds the voltage through the RRA. It converts AC to DC and feeds the main rotor. For feeding the exciter rotor, there should be some potential required. So voltage. So that is fed from the exciter. So for the exciter, there is again a AVR which is required to give the input. So for giving the input to the AVR, there is a shunt input. So this, how we call this as a shunt, there is a power input to the AVR comes from the same output winding. This is a shunt type of excitation system. This is what one variant. Probably there are some advantage, there are some disadvantage on that. Probably we can have a different one to have a comparison on the shunt, RF, and PMG, how it is going to have with the load application. There is a big subject on that. We can discuss on that. If any question during this particular one, you can mail me to Mr. Prakash, and I'm very deliberate to share this information on that. Coming to the separate excitation system, which is a 3-mission system, I would say. Fundamentally, you have seen the previous slide, the same one. This is also same. But you can see a different body who is a new fellow is coming and sitting over here. So this is a 3-mission system. Earlier you had a main stator, main rotor, exciter stator, exciter rotor. It is a 2-mission system in previous one, shunt. Whereas here you have one more machine like 3-mission system where PMG is going to come. PMG means permanent magnet generator, where it has its own rotor and there is a permanent magnet. You all know fundamentally when there is a North Pole and South Pole, you keep a rod. Because of the magnetic motor force, there is a rotation in the conductor. That is the basic of it. So that is how the PMG works. It has got independent voltage which can feed the AVR. There is some advantage on the motor starting and the nonlinear loads for this application. So preferably some of the designers do for PMG for a larger generators to have a black start or a higher motor starting. So this type of concept has been required by the demand based on the application and the customer requirement. The PMG is being designed, and this supply will be fed to the AVR. So our brain, that means the communication comes from heart to brain here, other way. In human, it happens other way. Okay, coming to this RF, maybe RF AREP, this has been fundamentally called auxiliary regulation excitation principle. Of course, this is a patent of Larry Sommer. You can see this winding where the cross-functional. Instead of the 3-mission system, here you will see the 2-mission system, but the RF will be 2 winding. That means X1, X2, one is voltage winding and current winding, which is given in the main stator itself. So that will be feeding the AVR. It is so advantage, as I was mentioning for PMG, there is a different source of supply giving to the brain, again the AVR. So this is going to be decide how much I have to feed to have the system, that means voltage, to the requirement of the load, or you have to have the voltage, current, and power factor. So this brain AVR decides how much I have to pump the excitation to the system, which we'll be discussing. So this is overall, if you can see, RF and PMG does the same one when we put it on the operational. As an experience of 30 years in this field, I look at this is also a fantastic design from the designers, appreciate for that. Coming to our heart, we have done with the shunt, PMG and RF. Heart has given some, always we have given some feedback. And of course the brain, AVR, our AVR, digital AVR. Earlier, pre-90s, there were a conventional analog AVRs were there. Before that, it was like a brushless, brush type generators were there. Thanks to the technology, digital technology, we move on. And I hope last 5 to 6 years in this field, it is moving on in a big way on the digital control system. And of course, we all come across with the COVID situation. Today, want to control everything from sitting from one place. And thanks to this digital AVR, sitting from here, you are in the generators in Turkey or in America or wherever the thing, we can control the system. And people are getting expertise in the digital AVR in India also. And this is quite a proven design. And this is also gives some more protection to the generator. Predominantly in analog AVRs, the answer was like more of the panel manufacturer or the OEM, which is going to supply the generator sets, do the protections. But thanks to the digital technology, where we have brought all the protections into the digital AVR, what has been seen across. So in this, how the AVR automatic voltage regulator works, our brain, there is some signals required. Of course, there is a voltage requirement. How much the voltage? My voltage requirement is 415 or 3.3 kV, 6.6 kV or 11 kV. So there is some control. There is a control voltage adjustment is there. UFRO, under frequency roll off. That means with the operating up, I am running at this much speed. I have to run at 1500 RPM. In India, we have been set across a 50 Hertz cycles where our engine RPM is thing, and fundamentally our frequency is 50. So this frequency set roll off has been set in the AVR, where AVR knows what time I have to feed the excitation, or what time I should increase the excitation or decrease the excitation based on that, or whether the RPM or the load. So this fellow plays an important role to match the voltage, so UFRO, and that is part of that system. So it gives a command. Again, for measuring the voltage, whether the voltage drop is there, there is a sensing circuit. If you see, we are crossing the signal, there is a policeman over there. So the sensing circuit is more of, he will keep monitoring us when there is a down in the voltage, like a policeman, he gives, no, you are coming down, so increase the voltage. So like that, this is a sensing circuit which has been done, and the active filters which has been put across for filtering some noise or another thing. So this is a stability part, sense loss, excitation limit. So overall, this excitation will be given to the exciter, to the AVR, wherein it gives the excitation system. So this is something indication gives, and it has been controlled by thyristor, as well as the latest design is of with IGBT designs are come up to reduce the noise. And finally, you can see this fellow is going to feed this. So to do the entire output of this many process and monitoring is very important. That is why I call this AVR as a brain, because we have n number of things to do, but brain says, yes, you do this, you do this. So that is why our AVR also does lot of comparison, take the information, judge it, and what to give, what not to give. So this brain does that way. Our AVR also does same way. And this is the AVR looks like a digital AVR, where the digital AVR have got 3 types where we can be used for all, thanks to the technology, where earlier analog AVR can be used for certain parameters and it should have variant. Thanks to the digital technology, today we play with the mobile, whether it is a Samsung or it is a iPhone or whatever it is, in a touch you can do everything. Same technology is put in this digital excitation AVR. And of course, the designers are so smart to give everything, all 3 in 1, whether it is a RF winding or a shunt winding or a PMG. this digital AVR, any make or anything can able to give that excitation system and controlling. And this regulator have got a power factor, excitation, current, and reactive. Earlier, we have a system on this, but we will talk on the detail one on this particular one, how this AVR is going to touch on that. But it is going to be very important for system generator safety also. So thanks to this digital technology, again, I'm appreciating the digital technology to the system, what it is going to be put across on the excitation system. High accuracy. Earlier, yes, everywhere we required accuracy. It's a quality man or a mechanical man. Of course, for electrical man also, it requires accuracy. Earlier, it was operating at 5%. It came to 1%. Again, it is a 5%, 0.5%. Now it's 0.25. This is what it can do fundamentally. So in what it can be built-in function, it can able to have the protection of stator voltage. It can diode fault detection, efficient load management, what the under frequency roll off or a load management system, built-in parallel operation between the generators or the grid. Both it can be done with a power factor or a KVR sharing, single phase or three phase sensing, which a customer demand. We can fundamentally in India, earlier it was a two-phase sensings were predominantly. We put one more module to monitor three-phase, but again, it brings with a three-phase sensing circuit, easily configure, customer-friendly. Anybody can do this, play with it like how you are playing with mobile. This is a customer-friendly one, and you can just see it in your own laptop what is happening in the excitation system or voltage happens. You connect a laptop, you can get everything. So it's a monitoring parameters. Always we keep monitoring the system so that is available. Optimize the regulation loop, which is very, very important when it goes for a regulation where the customer demand like data centers coming across or critical equipments like commercial buildings. A small light flickering will irritate some people, correct? When power fails, a light flickering happens, we don't allow that. So this is a technology which has been brought across to meet that requirements. Displays and fault, it has got its own advantage, like giving the events log or a false, what are the historic graphs we can able to extract. All you can say demand this from the digital AVR. So this is a soft start. I was just mentioning earlier, you can do all this soft start, voltage excitation, current limitation, protection and faults, bus compensation. All this thing earlier they were doing with different. Now this AVR is going to give a communication to the system where you are fault. So it is more of an integral system of the generator now. So this is how the parallel operation. Earlier, like there are like controllers like DIAF or Woodward. They talk each other. They means when the generators parallel operation is going on with the three generators, they communicate each other. That is how the system requirement. The same feature is available to communicate each other between the AVRs. So the digital AVR can communicate each other when there is this thing. When there is a load demand, how much we want to increase or decrease, we can play with this digital AVR. One is the voltage regulation. And of course, what I was mentioning, the CT, very, very important component to balance the load. I was showing in the previous slides where the reactive troop or active troop, what you can want to do that, we can play with that. If there is a load demand, we can also give a reactive demand, a reactive troop. Excitation current regulation possible. That is one of the requirement for the bigger generators where your integral system is there. Like we are checking our blood pressure. How much is my blood pressure? And this is happening. So this is monitored by AVR. Like how you are monitoring externally, the blood pressure of the system, the AVR excitation is monitored by the digital AVR. So this is what the voltage you can see. I'm just given for this to have a small understanding, which I want to talk on the later stage, which is the voltage. Again, 414 volts and the sine waveform and the vector, what you can see, 120-degree phase shift, which is going to be happen. So whereas the unbalanced load, the vector will not be the same. It will have a difference in the vector. And this is what your current, always the voltage, the current follows the voltage, we call lag. If the voltage follows the current, then it becomes a leading. So we should be on the generator should be operating on unity or a lag, where it can also operate on some condition to the leading, but there is not good for it, which will share it on the particular information. This is again an important frequency. This AVR monitors also the frequency, what it is going to be put across. And this we can see in our own digital AVR, what it can be done across. This is previously monitored from a different machine, different monitoring equipment. Today, you can monitor your own frequency of the voltage frequency in this AVR. That is the advantage. And all put together, it comes to your kilowatt, kVA, and kVR. This is what our fundamental, which is going to that in a generator. 3 parameters, kilowatt, again, it related directly to your power factor. And kVR, it is a reactive power, and kVA is the active power, what is going to be put across on the generator. So this is how the power factor plays. When there is a apparent power and real power, you can see this is the basics. I'm just trying it to touch across. Why I'm putting it across? This is all fundamentals. You have to connect a meter and monitor. Today, you have in digital AVR, you change over or move it. This will give a better to the generator system protection as well as the AVR. Okay, this is one important. Mr. Prakash, I can take another 5 minutes, right?
Yeah, no problem. Yeah.
Okay, thank you. So this is one part of a system. Today, when I say Srinivasan weight is 70 kg, and he can able to lift a weight of 50 kg, and he can able to run at the speed of 10 kilometer speed or a 15 kilometer speed. So everything is defined based on the body, correct? I can climb this much step, or I can able to do this. Same like that, what you described about a person, the same thing is being prescribed by the generator in terms of capability curve. What I can do, what the generator can do. So in the left hand side, you can see I was just talking about the voltage follows the current. It becomes a leading, and current follows the voltage. Again, it's a lag. So intermediate, you can see the center line, it is the unity power factor. So a generator capability curves talks about with the 3-point sets. You can have to the stator current limit. Again, you can have the field current limit, which I was talking about the excitation current. And again, we can have to the stability kVR, that means reactive power absorption on the generator. So the 3-point setting, earlier, if you ask me on this analog AVRs, this many settings were not that integral. It is, I cannot say no, it was there, but the integral part of the system is there. The answer is we have to put a lot of other connected equipments to monitor this. But today the scenarios with a single AVR, we can do that. That's what the brain is doing it now very efficiently. So this is the zone, and Srinivasan can able to do certain work with his own limitation. This is his limitation. You can see that on the right hand side, you can see the power factor. That means 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Generally, the generators are designed to work from 0.8 to the lower power factor. Of course, if you can ask me the question, why not to unity? Yes, it can work for unity. Why not leading? Yes, if the generator has the capacity, whether the Srinivasan can able to run 50 kilometers per hour, or means he should have that body scope or the design, or he should able to have a physical or a strength to do that. Like that, the generator capacity kVA should be also selected so that the machine can be there. This is why the designer plays an important role in giving the machine selection of the people. So this is very, very important, which normally, generally, this has not been discussed in the field or people. Capability curve. So any selection of your load with respect to your demand on the generator on a bigger 1 megawatt above, please do refer to the manufacturer and take this capability curve. And with respect to that, you have to go for a selection, and the manufacturer will give a right setting point to this 3-point check. So why I'm saying the field current, this is a part of our excitation system. Again, where the brain will say how much to I excite, and stator how much I can take the load, and the reactive power how much I can absorb. You keep more than 1000 kg, I'm gone. So that's how these limits have been set. Earlier the protections were outside. Today it has brought inside the generator. So that's why I'm been appreciating this technology of digital technology. So there's a rating point, what you can do. So coming to the next point on this, the limitation set, what the 3-point I was mentioning in the previous slide, previous slide. So this is what the short circuit current, the stator current. For example, if it is a 10 kVA, 14 ampere is that. If it is 100 kVA, 140. So 3 times is my short circuit current for 10 seconds. So earlier, how we'll decide about the short circuit current? There should be somebody monitor that. So that monitoring is done by AVR here. So AVR can do that. And again, for the excitation, how much is the tripping second? What time period it should? This also can be set in the excitation limit. My excitation will remove this thing, what you call powering to the exciter. So the voltage collapse and the generator will be out of the system. So that it protects the generator from the over excitation system, even though the demand has come to that. Of course, the failures are there to happens in certain non-proper setting of this one. So this is where the experts like manufacturer come into the play. A good commissioning engineer is going to come to the play. A good commissioning engineer is like whenever a person gives a birth, he writes a kundali or what do you call horoscope. So this are the something like you have to write a proper horoscope or a kundali for this generator to perform well. So that's what I would like to share. This is again a generator protection in generally, which I was not in the AVR, where it happens with the system, where you have a relays and protection relays, overcurrent relay. I will touch on that to give it more on that, like undercurrent, unbalanced, thermal image, instant high voltage threshold overcurrent, and time delay fault and rotor lock current. So these are the parameters where you can have earlier one, and today certain parameters our AVR takes care of it. Today this gives a feedback to the system. Yes, I have got some problem. Please remove from the system. So that is the one I am pushing it across, or talking about the digital AVR technology. Coming to our generator standards, this goes with the standards of IEC. As per anything goes, we have to be with standard. Of course, with the part 1, there were IS 4722 was there, which has been taken off by our standard team, and it has been 60034, which has been the part of it. Again, for a rating, there is a different one up to 20 kVA. Some rating, some will be given in the part 1, and part 2 have up to 1250 kVA. For the turbine application, there is a different one. So this is a different international standards. The generator standards have been inbuilt. Okay, so coming to the interactive session, Mr. Prakash, I can be open to take any questions if anything there.
Yeah, thank you so much, sir.